Yeah, so
Okay.
thank you. So Scott, the intent here is for us to figure out how this sort of plugin is used,
Mm.
like to generate that report, to run it. Like, for example, if I have a project, I want to run it, and then it generates for me that sort of report, right?
Well, my first intention is to find the entry point to the application. Since like Leonardo said, it's hard to figure out how these asynchronous kind of applications work. So
Oh,
you have to find an entry point. So from there, it will spawn off various threads that could do things. But until you know the entry point, you don't know where the top of the thread tree is. So um, so I'm just trying to go from what I do know to what I can figure out. So
I get it.
yeah. So what I do know is that it looks at a Git repository, so it can generate this report, and it goes and analyzes it. Um, and and so and I know it's a Maven plugin, so I just decided to start here because I think it's most likely here. And we've got this refactor first Maven report, and it has an execute method, which seems like a reasonable place to start. I'm just making a number of assumptions at this point because I don't know for sure. I see that it creates a bunch of strings. It has this string builder that it goes in and generates a bunch of stuff. My guess is that it uses this string builder later as it's generating the report, but at this point it's still building it up. So here's your project name, your project version, and we get the project name from the project, which is a parameter that is populated by Maven somehow. If I knew Maven better, I would probably be able to understand. So basically it checks to see if the optional Git dir is present. Otherwise, we don't have a Git repository. Then it ends. Okay. So basically, you either pass in a Git repository path, or it runs on the local directory and says that the local directory is a Git repository. Otherwise, it says I don't know where your Git repository is. Okay, I got that. Get the parent file. So now it starts opening the files in your Git repository. So it looks like this Git dir. Okay, that's a file. All right, so he basically opens and everything is text files, which I don't know if you're familiar with how Git works. Go in here, look at .git. All the all the stuff in a Git repository is text files, I believe. Okay, so what do I know?
No, just a second. Scott,
Yes.
there. Now, is that referring to the Git files of this project itself, or the Git files of the project it's being run against?
This is the one that it's being run against. I'm just looking at that's what it has. So
Okay.
logs, refs, heads. Oh, where does Git have its info? Nope.
Books. Yeah.
Objects. I thought it was in objects. Pack?
Yeah.
No?
Could you move back a bit to the code? Because I saw just
Sure.
what they did is simply to read the directory, the Git directory, and then check the files. And if
Yeah,
present, get path. So
present.
get parent file dot
It's
get
a base
path.
dir, parent of the Git dir. Okay. All right. cost benefit calculator. So it creates a new cost benefit calculator, calculate the cost benefit on the project base dir. So I bet that starts digging into it. And ranked disharmonies. All right. Cost benefit calculator.
I think I'm getting what's happening. Well, we know one of the features of this tool is to show how often the classes are changed, and the way to do that is by checking the Git. So
yes,
I think it traverses all the directory hierarchy. So you needed to go to every, because we know that in every directory we should have a .git directory. Okay, so I think it tries to look for every .git directory in every folder of the project. Okay, and then in that .git we will have the Git files that will show the information that this tool needs in order to determine how often the files are changed,
right.
But I think that that's the idea, at least. So it relies on the Git repository of every subdirectory of the project, I believe.
Right. So evidently, this ranked disharmonies would be as something. It has your list of God classes. Your God classes would be your great big ones like this. That's you know what a God class is. It's something that does everything. So you just pass it around everywhere because it's got all the data. So this looks for God classes. And if you don't have any God classes, then I guess it's got nothing to do. God classes by the numbers. So, and then it goes and generates this report, which is all in your ranked disharmony. So it looks like all the work is done in this function here, this calculate benefit values. It gets us the ranked disharmonies. And all this stuff, it goes in and dumps all the contents of that object into the report. Done, view the report, and then it spits out the log, and then it writes it to disk. Okay. And then write gchart.js. So yeah, that evidently formats this chart here. So let's look at how this ranked disharmonies gets generated. That would be passing the base dir to this calculate cost benefit values. So this is in the cost benefit calculator. So where's the cost benefit calculator? You see how I'm using the IDE to help find my way around here. So the cost benefit calculator is in this other project, the cost benefit calculator. Isn't that cleverly named? So we've got our get log reader and our repository. And it logs everything we're doing. So we get our repository. We get the God classes. Get the range change proneness. So this is our change proneness over on this column here. So we'll get the change proneness, and then ranked log infos by path is, so we collect all this stuff. We map it, we log the information into this map, okay? And when we have, and then we stuff all of that into this ranked disharmonies. Okay, so everything is in this ranked disharmony.
So basically we have the God classes, and we also have the the ranked log infos by path that somehow is based on the SCM log infos. Okay, so because
Right.
the SCM log, first you get the God classes, and then with the God classes, we pass the God classes to this method called get ranked changed proneness. That is what you shown us,
Right.
this vertical line, you know, and then in the end we have this. We run this, we create this, oh, look at that, we create any stream on that, yeah, exactly. On top of the SCM log infos, we create a stream, and then we process every item, and then we create a map based on that, that in the end will be exactly, we will have this. So I think that a crucial part of the logic is in that part, so where we create this map.
Right. Now, I'm at one level, I'm wanting to understand how the code works, but I'm also at a meta level, understanding the process that I'm going through. I'm just taking a small chunk that I can understand. This is reasonably well-written code. So he's worked hard to make it readable. So this is good. We've seen other projects where it was barely readable and it's just a pile of clutter. When you find clutter like that, it's helpful to do what I call a temporary refactoring, where you'll break it up into smaller pieces. And that's why I was talking at the beginning about our different levels of memory. You've got your short-term memory, your long-term memory, and then your working memory. So if I can break it up into a small enough chunk that I can put it in my working memory, from there I can move it to my short-term memory, and from there it can go into my long-term memory. I can begin to understand how it works. So that's basically what I'm trying to do, is say, okay, I understand each little piece, and from there I can then start digging deeper. So we get our guide class, we get our ranked change proneness, and then from there we go and map it, and from there we create this ranked disharmony object from the map. So that's how we're building up all the information that we have. So let's look at, the God class seems to be the basis of everything. So I'll do a control click on this and see, how do I get the God classes? This is still within the cost benefit calculator object. So we've got our repository and our reader. So we're going to go through, we're identifying God classes from files. And so he's got some nice logging in here to explain what's going on. List repository contents at head. Okay, so it starts at the head, which we look at Git. Here's our head. So if we open that and stop that, we open that, ref heads main. So we can go to refs heads main. That's where it's going to start. And it's got some number. So that's our number that it's going to be looking at. Contents at head. So, and that will be our files to scan. And then PMD God class rule runner. That sounds interesting. So that's a whole, I guess that's basically got all of our rules for how we're going to determine that something is a God class. And then, so we will have our list of God classes, and then our list of files that we're going to be looking at. And we're going to just step through each one. So we'll get the file path and the byte array output stream, which is our file contents. Stick that in input stream, and we'll run that into the run God class rule in the rule runner. Okay, and so I guess that determines if something is a God class. And then if guide class option. So basically, if it finds that it's a guide class, it will add it to our array. And then we have a guide class ranker, so it figures out which one is more godly than others. Okay, so let's start digging deeper into this. Let's look at this God class rule runner and see the God class rule. So this is a whole new object. So where is that? We look at our little target thing. This will tell us where it is. The God class rule is in the effort ranker. So here's our God class ranker, and the PMD God class rule runner. So PMD is another static analysis tool. So my guess is that he is relying on PMD as a tool to determine if something is a God class. Yeah, so PMD, SourceForge. Have you all heard of PMD?
Yes.
It's sort of like CheckStyle or what is that? I'm drawing a blank now, but basically it's a static analysis tool that will go in and look for code smells and report them to you. So run God class rule, so that runs PMD. Well, run PMD is your God class rule runner. Yeah, so, well, let's see what run PMD does. It uses lots of deprecated stuff in here. So rule context, says the report, opens the file, rule violation. Okay, so it does the process of the source code and then looks for any rule violations in the source code processor, which is your PMD. And so if it finds a rule violation, it goes and creates a God class object, which lists the class name, what source code file it is, which should be very similar to the class name, since it's Java. It's a package name, and the description of the violation. Okay, so and I guess we can set the Java version you're using. May need to specify that. Report PMD will return. Okay, so that's a to-do. So I can see how this works, how it does its analysis. It uses the PMD checker to do that. So do a Control-Alt back. So that's how it runs the God class rule. And then we've got this God class ranker, and it ranks the God classes. So let's see how it does that. Rank WMC, ATFD, TCC. And it was created by Wendy. That's important to know. So I don't know what WMC, ATFD, TCC is. Oh, here's rank WMC. Calculate weighted method per class. So I will do this so we can find our way in here. Weighted method per class. It sorts get WMC. How does it know what WMC is? So this is in the God class object, which is right here. WMC, parse extract value, values 0. What are the values? Result substring index of split. So that's results. We pass in results. So when we create the God class, it's got a result. Well, now I'm confused. So we've got a list of God classes. So, and then we rank the God classes, get the God classes. So where do we create the God classes? Did I just forget that, or have we seen that?
No, there's a list of God class. Look at the line of on the line 81. We create an empty list of God class type.
Right. So
Then
we add
in this block, this four, somehow we create the God
run
classes
class
and
rule.
yeah, and then we add them to the list. This is my understanding. How, I don't know, how we create actually the object, but I think it's
Run
okay
PMD
beside this.
evidently goes and creates the God class. So
Oh, okay. So the
So-
run MIDI will produce the, yeah.
unknowable God class. Optional.
Yeah. Look. Line is 7. Yeah, new God class. Yeah, line is
There we
7
go.
and 7. Yeah. That's
Very
the
good.
place.
All right. So, okay. So, well, this tells us how it gets created and how we use this description, which evidently is a comma separated string, to go and determine what its rank is. All right. I need to go ahead and start wrapping things up here. Was this helpful for you, Leonardo? Does this help you in understanding how we kind of dig through it and break it up into smaller bits?
Yeah, I will read I will search for the book you provided,
Right.
the
This-
programmer's brain.
The programmer's brain.
Programmer's brain.
I find it. You might look for Felina Herman's. She has some videos on YouTube where she explains the concepts behind the book, and you know, that might give you enough. But if you want to go deeper, definitely look at the book, because it she refers to various tools and approaches that she uses to look at code. And she also has, it's called the Code Reading Club. Code Reading Club. So she started this Code Reading Club thing, and she has a blog where she explains what it's about, and it's got various tools, and it's a group that gets together once a month and just looks at some unfamiliar code and figures out how to read it. So if you really want to do a deep dive into code reading, but yeah, this is, I mean, complex code is it's hard to read. For instance, one thing I noticed is, you know, we're using a lot of lambdas here to do things, and using the lambda notation. I'm not as familiar with lambdas as I should be. And, you know, like I didn't, I don't know what this of nullable function does. And
You are a Java 4 like me, like a Java 4 guy.
yeah. So, so a lot of times that, using more advanced language features will make things harder to read as well. So, I mean, it just takes some extra time to do that. And the more you do it, the better you will be at doing it. So that's why I recommend that you dig into unfamiliar code and you figure out how to read it. So we'll leave it at that. Any y'all have any questions or concerns? Oh goodness. Who do we have here? He's coming. Hey there. Hey Bruno.
Hi.
Yep, we're wrapping things up. We you're in Brazil, aren't you? No, you're in Canada.
Yeah, Canada.
Yeah, Canada. So you've got daylight saving time. So or you've just ended daylight saving time. And so now we
Yeah.
start an hour earlier.
Okay.
But I recorded the end part of this. So
Okay.
Okay.
No, it starts now at 7 a.m. 7 a.m.
yeah, it will start
Yeah.
at 7 for you.
Okay.
6 for
Okay.
me. So
No problem. I forgot. I forgot.
that's not a problem. So so yeah, I will get the recording put up hopefully later today. I've got to run to a meeting, and we'll have to leave it there. So does anyone have any other questions?
I just would like to share my takeaway from this session.
Okay.
And it seems to me that that's my feeling. It's important to try to identify the major component of the code and try to understand how they are connected. And it seems that we somehow try to do that. We tried to identify what's the first step, then the second step, then the third step, but in a high level. And once we have this high level understanding, we can go a little bit deeper. And for example, when you started to, okay, but how will we create this God class, or where is the method that will do this specific thing, But in order to do that, first we need to understand the big picture, the major flow, and then we have that, or also we believe that we have that. Okay, so I can start to go deeper and deeper and deeper into the other layers of the solution. Okay,
Right.
but I find it quite useful, Scott, this approach, to try to start with small steps, identifying the major components, how they are connected, and from that and I think this is related to this short memory idea. We needed to commit to our brains what's relevant to allow us to go deeper and deeper, and by having this important knowledge in our short memory, we can use that to go further and further and further. Okay, so at least that was my takeaway from this session. Okay, thank you.
Right. Okay. Yeah, that's really, I guess that's a good summary of what we discussed today. So, thank you.
Yeah. Again, thank you, Scott. Maybe again, like what Davi said, because what I understood here is when you write the code, your code, it's in your memory, you fully understand all the steps of the code, like what it's doing. So when you're reading unfamiliar code, this concept of how the brain works is you're trying to get the thought process of the original writer of this code. So now what you've just demonstrated here is to get to understand like how it was moving, like the map of the code to fully understand. Like now you're reading to understand the code. and you're now
Yeah.
trying to interpret the thought process of the original writer of the code, and that is very important.
Right.
It's a very great feature, yeah, and attribute when you are trying to read the code. Thank you so much
Yeah.
for that. Yeah, maybe the other thing I identified in the code is this guy used a bit of, he nested a stream within for loop, which creates a quadratic sort of like big O complexity. What is your opinion on that, Scott?
It could be. I do
Mhm.
not know.
Mm,
Yeah,
okay.
I'd have to dig into it more deeply and see, but yeah, I don't know. Sorry.
Okay. Thank you. It's okay.
One question to you, Ali, because this is a very good observation of the structure, maybe the architecture. Do you think that by looking into the package structure of this project, would it be possible to guess, for example, this is one component of the solution, this is another component of the solution, this is another component of the solution? Because by looking into the class, the name of the class is the name of the package, so I couldn't guess the architecture, the components, the layers of the system, and well, this is something important for me. Whenever I go into some unknown code, I try to look into the package structure, the name of the classes, to see if they make sense. In this case, do you, Ali, and you, Scott, and everyone here, do you think that this project somehow help us to get an understanding by just looking to the name of the classes and the name of the packages to understand what's going on? Or no? Do you think that it's not so straightforward, it's not so obvious? Or do you need more and more time to assess this in order to answer this question?
Maybe to go fast, I would say yes and no, because there's like that weighted method count thing that was abbreviated that couldn't like maybe on the first sight tell you exactly what's doing. But then using Scotty's method of trying to follow step by step, it comes clear at the end of the day, and you appreciate maybe the guy was trying to save time or whatever to just abbreviate it that way. And then it goes on linking as you keep going, but then it's not as clean as you would expect. That anyway, why wouldn't someone just write weighted method count or something like that? Maybe that's my submission.
Yeah.
Mm.
Yeah. Well, one thing that helps to clarify things is have a pad of paper next to your next to your mouse while you're working on this, so you can take notes and sort of draw out the structure of the objects and their relationships as you're looking at the code. And then likely the names that he's chosen will make more sense. But sometimes, like someone had abbreviated some names for some functions and that sort of thing, and I was like totally confused. I don't know what this WMT is. It's like, oh, okay, this is a weighted whatever it's called. So I was like, okay. So the abbreviations tend to be confusing, so don't use those. But for the most part, yeah, the names were helpful. So yeah, I agree with Ali. Yes and no. Some parts were helpful, and some parts were not as helpful.
It only works if the code is well written. If it's a bad code, it doesn't help it to read the names, the packages.
Right. Yeah. So your poorly written code will always be confusing. But I mean, even there, sometimes the names are helpful and sometimes they're misleading. So yeah, I basically, like Ronald Reagan said, trust but verify. You want to dig into it and see if it does in fact do what the name says, and then you may not, again, like I said before, I'll do a temporary refactoring. So if something has a bad name, I'll just go and refactor it and give it a different name. I won't necessarily save it that way, but I'll just to make it easier to read and understand, I will temporarily go and change names and break
It's
things
inte-
up into smaller pieces.
it's interesting because all will work in the class, in the project I work at now. We do the refactor the variable always, because or is in bad English, bad name, or
Mhm.
is in bad French, bad name French. So
Oh dear.
yeah, so it's always refactor the variable, and usually is in French. Change the English to French and clear more French possible.
Okay.
Yeah, because the always in English, almost, and how I in the Quebec province, so the French is the principal. So change the English to French is the more clear French possible.
Yeah. 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 That makes sense. Well, again, your French is better than mine, so you'll be able to understand that better than I did.
Yeah, it's funny because a method it's get something, in French say is something, so it's the change the method, the number variable, always everything.
Right.
Yeah, maybe a quick one before we leave. It's like any other business. I wanted to understand if we still have some time, Scott, to understand something here we are doing at my workplace.
Mhm.
Maybe you would either give me some suggestions or challenge me. So we're doing something, we're reading some data from legacy code. No, not from a file, Excel file. In Spring Batch, and then we're keeping that data in a DB like Mongo. But then we have one technical challenge that this file from a legacy system is cumulative, like they're sending all the records from the beginning of when the legacy system started working, like hundreds of thousands of records every day. So for new business today, for example, if 1,000 sort of more new records have been added, there will be 100,000 like and 100 records, the new addition, you get it? So basically you have to look through the whole file and pull out those new, and then you add them to the DB, okay? And then also for the old records, maybe if they change, someone changed the name or whatever, you need to look through the whole file and compare with the DB to change, to update, like that sort of new record or the old record that has been updated. So now the solution I had like in the design on table was to sort of use the Redis catch to catch, like maybe for example, the IDs, all the IDs of the record in the DB, I catch them in the Redis. So every time I look at this new file they're sending to filter out the new sort of records, I just keep comparing them because Redis is like a dictionary, or I would say a map that I compare like linearly while I'm going through the file. Here it's constant in the Redis. So basically it takes me like constant time to check Redis to just see whether this ID exists in the DB. And then that way I can get to know 100 new ones, new entry in linear fashion without checking through.
Right.
And then for also the old ones still, I have sort of a stringified sort of all the columns. Like for example, the entries of one row I stringify it into one string so that I compare a string with a string, and I know that anyway, this is the same. Yeah, just in one comparison, the string versus a string, and I can also it's a linear fashion. So my question here is that sort of what do you think about that solution using Redis to cache? Because ideally it's very expensive sort of memory to use for that purpose. So the question here is, how do you see that?
I think it's a clever solution because frankly, memory is cheap. and
Yeah.
Processing time is more expensive. So, but I guess it depends on your access to resources. Is memory really that available that you're able to get away with that, and it's not a big problem.
It is. The infrastructure team was like, it's okay if you guys think it's a good design,
Okay.
and you can go ahead and use that. So yeah, but maybe I was thinking if other engineers could have a better solution without using caching, maybe because the other solution are like keep checking the DB every time you have the record, you hit the DB, hit the DB, hit the DB, like
Yeah,
that, and it can end up
that's
into a
gonna-
quadratic sort of
Yeah,
complexity.
that'll pound the heck out of your database. It's going to use up all your IO, and that's, I mean, that's going to use a lot more resources. I think the solution you came up with is pretty clever. So
Oh, okay. Okay. Thank you,
Actually,
Scott.
I have a question to your solution. So this database is where you have to check, to compare the data if it has changed or not. This database is the same one that is used by the users.
Yeah.
So one alternative maybe would be to have a read-only. You could have two databases. For example, you have it. For example, if you don't want, if your concern is, well, I don't want to put stress. I don't want to, for example, fall in the condition where I have in one side the users accessing the database, and then in the other side my solution connected to the database to see the differences. So maybe you could have a replica. A replica where a read-only replica, something like that, just to check the data, and one replica where the users would access. And then by doing that, you could like kind of separate, you know, just an idea, I'm thinking out loud. So maybe you instead of having, if you don't want to use a Redis, you know, so maybe a read-only database, a mirror, you know, so to speak, that would be used only for this purpose of checking the data. But well, just an idea. I don't know if the implications or what would the impact, or even if that's feasible, but just an idea that it came to my mind while you were explaining the scenario.
Okay. Yeah. Thank you for that idea. Maybe a quick question on that, because ideally, if you are hitting the DB, it means every time you have to check, because the DB, the way it stores info is not like a map, Redis. Because ideally, every time I have to check whether your ID exists in that DB, I have to maybe select or find whatever. So it has to go linearly through every single record to check whether you exist. So it creates some sort of O of n squared, that for every record here I check, every record here I check, every record here I check. So the time complexity is crazy if you are using a DB against sort of checking record. So for 1 million, it would be 1 million squared sort of transactions in that manner. So yeah.
So you are talking about a read-only. So it's very read intensive, you know. So in this case, I have heard about solutions like Solr. They are databases that are optimized for reading operations, you know. So when we have the situation where you needed to read data so often, what people they index the relational data that they have in the database in a like really optimized database like Solr. You know, so instead of Redis, you could put in front of your relational database a Solr, and then you could get this information because in solar they are optimized for that, to lots of reads.
Right.
So yes, I have used it also solar before because the reason I'm sharing this thing because I remember that I used to work in a company where the guys, they were complaining that, wow, the SQL query is expensive. Like you said, they said, wow, we cannot go to the database and run these selects because they consume too much resources. And then someone came with this idea, okay, so let's use something like solar because solar is for that. And they discovered, it turned out that, for example, a query that would take, for example, 10 seconds, just an example, to run on SQL, when the same data, to get the same data from solar, you would decrease the time to milliseconds, something like that, and it would be less resource consumption and faster. But again, I don't know if this solar would be something good for your scenario, but it's something to consider maybe.
Yeah. Thank you, David, so much for that. I'd not used solar before, but it's a good suggestion. I'll look into it. It's a clever suggestion. Thank you so much.
Very cool. All right. Well, there's no more questions. I need to get going. It's good to see y'all. I'm glad we got Bruno got to join the discussion somewhat, so this is a good thing. And I'll track down the our other new guy and figure out what happened. Make sure that he knows where to find us. But y'all have a great week. If you have any questions during the week, please feel free to reach out, and I will get this video up later today. All right.
Okay. All right.
Thanks,
Next
guys.
Saturday, I will be there.
Okay.
Thank you.
Thank you, guys.
Bye-bye.
Good
Yeah,
week.
guys.
Catch y'all later. Bye.
That's
Yeah.
it. Bye.
Bye.